You've seen AI write an email, a poem, even code, right? It feels like actual magic. But the way it learns is, weirdly enough, both super simple and just mind-blowingly huge. So let's pull back the curtain and see how it really works.
Yeah, we've all seen it. You type in a prompt and out comes this perfect text. But that's the what. We're here to talk about the how. I mean, how does a chunk of code go from zero, from knowing absolutely nothing, to mastering the subtleties of how we talk and write?
Okay, so it all starts with reading, but not like you or me reading a book. Imagine a library that contains, well, basically the entire internet. We're talking about a collection of text so gigantic it makes every library in human history look like a little bookshelf in the corner. And honestly, getting your head around this scale is the first big step to understanding any of this. Just look at that number, 15 trillion. That's not pages, that's not even words. That's the number of tokens from just one of the big data sets they use for training. It's a number that kind of breaks your brain, right? So what on earth is a token? Think of it like this. A token is the AI's version of a word, or sometimes just a piece of a word. It could be cat, or it could be just the ing at the end of running. They're like the basic Lego bricks of language for the machine. So that 15 trillion? That's 15 trillion little Lego bricks that the AI is going to learn to snap together in the right order. All right, so we have this mountain of Lego bricks, a truly epic mountain. What does the AI actually do with it? Well, this is the wild part. The entire super complex process of learning language, it all comes down to playing one single, simple game. Yep, that's it. The whole thing is just guessing what comes next. Seriously, a large language model, deep down, is just a ridiculously powerful prediction engine. Its only job, the only thing it's trying to do, is look at some text and guess the very next token, over and over and over again.
So let's make this super concrete. The model gets fed a little snippet of text, a sequence of tokens like this. The cat sat on the.
So what's the next word? Come on, you know this. Your brain, without even trying, probably served up mat, or floor, maybe couch. You just did a super fast probability calculation based on every time you've ever heard or read that phrase. The AI is learning to do that exact same thing, just with a whole lot of math.
Okay, and here's the really critical part. When the AI makes its guess, it doesn't just spit out one word. Nope. For its output, it calculates a probability score for every single token it knows. And for a big model like GPT-4, its vocabulary has over 100,000 possible tokens. So for that one empty spot after the, it's weighing over 100,000 different options against each other. It's nuts. So how does it get any good at this guessing game? I mean, it can't just know the answer, right? Well, you're right, it doesn't. It starts out terrible. It learns through this constant cycle of trial and error, a kind of learning loop. And this is where the real intelligence starts to emerge. At the very beginning, the network is basically a newborn. It's a blank slate. All of its internal connections, these billions of things called parameters, they're just set to random numbers. So if you show it, the cat sat on the, its first guess might be bicycle or purple or just total gibberish. It has absolutely no clue. The whole training process boils down to these 4 steps, just repeated an insane number of times. 1, it grabs a random piece of text from that giant library. 2, it looks at the beginning of it and predicts the next token. 3, it then looks at the actual next token in the text to see if it was right. 4, and this is the most important part, it measures how wrong it was and then slightly adjusts all its internal knobs and dials to make the right answer just a little bit more likely next time. And when I say a tiny bit, I mean tiny. If the correct word was Matt, and the model's guess was way off, it doesn't just flip a switch and say, okay, Matt is the answer. Instead, it might just nudge the probability of Matt up from, say, 0.01% to 0.02%. It's a microscopic adjustment. But here's where the scale comes back in and blows your mind. One of those tiny little nudges does basically nothing, but the AI is doing this loop, predict, compare, adjust, trillions upon trillions of times. It's like erosion. One drop of water does nothing to a rock, but trillions of drops can carve the Grand Canyon. All those tiny adjustments, added up, are what slowly, gradually sculpt the network's understanding of language. Okay, so we keep talking about this network and its internal knobs. What is actually going on inside the machine? We're not going to get super technical, but let's just pop the hood for a second and look at the engine that drives all this, which is called the transformer architecture. So, a few key pieces. First, every token gets converted into a long list of numbers. That's its embedding. But the real secret sauce is a clever mechanism called self-attention. This is what lets the model look at an entire sentence and figure out which words are most important to which other words. It's how it knows that in the sentence, the robot picked up the ball because it was heavy. The word it refers to the ball, not the robot. That context is everything.
Honestly, the best way to picture the whole thing is like one giant, incredibly complicated math equation, an equation with billions of variables. And that whole training loop we talked about, that's just the process of slowly, painstakingly finding the perfect values for all those billions of variables so that the equation gets really, really good at predicting the next token.
So we've gone through the process, trillions of guesses, trillions of tiny corrections. But what's the end result? What has the AI actually learned after all this? How does just playing guess the next word lead to writing poetry?
And this, right here, is probably the single most important thing to get. The model doesn't know things the way we do. It doesn't understand love or sadness. It's not conscious. What it has done is build a phenomenally detailed statistical map of human language. It's learned the probabilities of how we string words together, and in doing so, it has accidentally absorbed the patterns of grammar, of facts, and even of different styles of writing and reasoning.
That statistical map is the foundation for tools like ChatGPT. So when you ask it to write an email, it's not thinking, okay, an email needs a greeting, a body, and a closing. It's just starting a new round of the prediction game. It predicts the most likely first token, then based on that, the most likely second token, and so on, stringing them together one by one to create something that looks like a coherent answer, all based on the patterns it absorbed.
Which leaves us with a pretty wild thought to chew on. All of this incredible, seemingly intelligent behavior, it all comes from being an extremely good pattern matcher. So, if something that looks so much like intelligence can be built just from recognizing patterns on a massive, massive scale, well, what does that mean about us? What is our own intelligence, really?